Right, hello class. Welcome to a section I'm calling Extra Examples. This is where I'm going to be doing some extra examples that didn't really work into the lectures themselves, because let's be real, the lectures are already long enough. But here is just, if you want to see me work more examples, more difficult examples than what's in the lectures themselves, and I'm going to try and start trying to trim the lectures, make them a little shorter with less examples, and then have these sections be more focused on the actual examples themselves. Okay, so this is going to be 2.3, okay, which is all about limits. Now the one thing I really want to reemphasize here is that to evaluate the limit as x goes to a of f of x. Well, we talked about in the lecture we have a strategy we follow, right? Step one is we try to plug in a. And if we can, then, right, the answer is f of a. If we can plug in the value and get a nice number, then that is the answer, and that is that, right? On the other hand, though, if we have a 0 over 0 case, so when we plug it in, so when plugging in a, if we get 0 over 0, okay, that means there's more work to do, right? So what we basically have to do is either factor, cancel, simplify, and then try to plug in again, go back to step one, or we have to use a conjugating factor. Right? And that's if you see this typically with square roots. Usually, and as we saw in the lecture, you can also be some sign stuff. Okay, so let's go ahead and look at some examples here. All right, let's start with this example. The limit as x goes to 1 of x squared plus x minus 2 all over x squared minus 3x plus 2. Right? So in these cases, right, first check by plugging in. So if you can see here, when I plug in 1 into the denominator, I'll get 1 minus 3 plus 2. That's going to 0. And in the numerator, I'll get 1 plus 1 minus 2. That's also going to 0. So this is definitely a 0 over 0 case. Okay. So therefore, I'm going to want to try one of my other options since we have a 0 over 0 case, right? So our first strategy here is to try and factor and cancel. So the numerator here should factor. I would want factors of negative 2. That will sum up to be 1. So I'm thinking x plus 2 times x minus 1. Okay. And the denominator will also factor. I'd want factors of 2. That would sum up to be negative 3. And that's going to be x minus 2 times x minus 1. Right, and we have, oh, look at that, the x minus 1's cancel, if you can see that. Right? Then just rewriting this is basically the limit as x goes to 1 of x plus 2 over x minus 2. And now I should be able to just plug 1 in, because when I plug 1 in the denominator, I get negative 1 down there. That's not equal to 0, so we can just plug and chug. Right? So plugging in 1, I'm just going to write it out explicitly. So you see that I'm actually plugging in the 1 there. Okay, and notice my limit sign disappeared when the x's did. There are no more x's, so I can drop my limit sign. All right, so this is going to be 3 over negative 1, also known as negative 3. And that's our answer. Okay, second example. Let's look at the limit as x goes to 1 of x cubed minus 1 all over x squared minus 1. Okay, so once again, this is going to be a 0 over 0 case, because when I plug in 1, well, in the denominator I'll get 1 minus 1, and in the numerator I also get 1 minus 1. So 0 over 0 means that there's more work to do. Right? So our first strategy, right, is to try and factor and cancel when we have a situation like that. All right, so we can factor the top. This, remember, we looked at this in the lecture, is a difference of cubes, right? If you have a cubed minus b cubed, this is going to factor into a minus b times a squared plus a times b plus b squared. Right? That's the difference of cubes. I'm going through this again because people forget this one a lot. It's a very common one to forget. And actually, we also have a sum of cubes, which the only thing that's different, we have a cubed plus b cubed, is we change the sign here, so that's a plus b, and we change the sign here, so it's minus ab. Okay. So this sign in here in the first term always matches what we started with, and this one, this middle term, in the second piece always is opposite. Okay, that's how I remember it. Anyway, so a here is going to be x, b is going to be 1. Right? So this will be the limit as x goes to 1, okay, of bx minus 1 times, let's see, it's kind of hard to see that one. Let's see if shifting down will help. Yeah, so it'll be x minus 1 times a squared, which will be x squared, plus a times x, which will be 1 times x, so x, plus b squared, which will be 1. And that is that. And then the denominator will also factor. X squared minus 1 factors, that's a difference of squares, will factor into x plus 1 times x minus 1. And we see that the x minus 1's cancel. Okay? So let me rewrite this just so we see what's going on. A lot of people don't really do this step, but I find for some it really helps. Remember, I'm writing my limit sign again. You will forget that, I promise, but try your best not to. So now we have the limit as x goes to 1, x squared plus x plus 1 all over x plus 1. And now I should be able to plug and shove, because what we really check is the denominator, and that's definitely not going to go to 0. That's totally fine. So plugging in 1, I get basically 1 squared plus 1 all over 1 plus 1. Again, you don't have to write this step out. I'm just doing it to really show that, hey, I am actually just plugging 1 everywhere I see x. So this is 3/2. Okay, next example, let's look at the limit as h goes to 0 of h minus 5 all squared minus 25 all over h. Now, here's an example that we haven't really touched on before. I mean, clearly, we can't just plug in 0, because if we do, the denominator is going to go to 0. Okay, and the numerator will too, because I'll get 5 squared. Right, 0 minus 5 will be 5. That'll be negative 5 squared minus 25. This also goes to 0. But this isn't like something where we can just factor. Yeah, I can't really factor this thing. But that's okay. Sometimes what you really have to do before you even get started is just simplify. Right? Let's just FOIL this thing out. so that I get the limit as h goes to 0, okay, of, when I FOIL this out, this will be h squared minus 10h plus 25. Right, so that is the, what was in parentheses here, then minus 25, okay, all over h. We get a lot of things canceling here, specifically the 25s cancel. So down here, let's continue this. The limit as h goes to 0. Notice I'm still writing the limit sign, right? And we're left with here is h squared minus 10h all over h. Now, many of you will see here that we're just going to cancel our h's, but be very careful here. If you know what you're doing, fine, just do it. If you don't consider yourself a math whiz, right? If you aren't that confident in your math skills, a lot of people will just cancel these h's and forget about this one. So my advice is to always factor. If you're not sure, right? If you're not sure that you can cancel across division, well, just factor everything. Right? Because I can factor an h out of the top here, and then it's very clear what cancels, what doesn't, what gets left behind. You know, it makes things far simpler. Okay? So just always factor. Eventually you can get to the point where you say, oh, this h cancels with one of these h's and that h. But if you're not there yet, that's totally okay. You can just factor, all right, and be just fine. Okay. So then we're left with this limit as h goes to 0 of simply h minus 10, and this is as simple as just plugging in 0 for h. Right? So we get negative 10. Again, I'm writing a bit more steps than you would ever actually have to write, but, you know, better more than less. Okay, next example. We're going to look at the limit as x goes to 9. Move this down a little bit. Of x squared minus 81 all over the square root of x minus 3. Right? So here we go with one of our square root examples. If I plug in 9, get the square root of 9, which is 3 minus 3, that'll be 0. That means we have trouble. We've got more work to do. And then 9 squared is going to be 81 minus 81, 0 over 0. Okay, so we see a square root, so we're going to want to use a conjugating factor. And the conjugating factor here, of course, I'm going to take the square root term, wherever it might be, and just change the sign. Right? So before I throw in the equals, I usually just do it right here and say, all right, this is going to be the square root of x plus 3 over the square root of x plus 3. Okay, and then I throw parentheses around everything just so I don't forget it. Okay, it's very easy to make mistakes here if you don't do this part. Right? So then, remember how this helps. I'm going to write this step pretty explicitly here. Let's start with the denominator. Remember, this is going to be this term squared minus this term squared. Okay. That is what helps there. And for the numerator, well, what I'm going to do is just leave it alone. Okay, so all of these, well, by leave it alone, I mean I'm not going to multiply it out. So with these square root type problems where you use a conjugating factor, there's going to be one piece that you will actually multiply out and they will help you, and then one you're actually not going to multiply out. What I am going to do though is factor this x squared minus 81, because what we'll see is in the next step, right, we're going to get that this is equal to the limit as x goes to 9 of, when I factor this, that will be x plus 9 times x minus 9 times square root of x plus 3, that's still left over, and this will end up being x minus 9. And so that's why I factored that, because those x minus 9s will cancel. If you didn't factor, you'd get down to this step and not know what would cancel and what would help you out here. So remember, you can factor everything out. In fact, we might have wanted to do that here at this step, since often simplifying the problem is one of the first things we ever want to do. Okay. Now continuing on, what we end up with here is the limit as x goes to 9 of x plus 9 times the square root of x plus 3. And that's just, I mean, there's not a fraction there, right? Very nice. So we can just plug and shove, plug our 9 in, and get our number out. So plugging in 9, I'm going to write it explicitly once again just to show what I'm doing here. Right, but this is going to be 18 times, right, square root of 9, that's 3, plus 3 is 6, so we end up getting 108. Okay, next example we're going to look at is the limit as t goes to 0 of the square root of 2 minus t minus the square root of 2 all over t. This should look really familiar, actually. This is very similar to the one we did in the lecture. Here, though, okay, we see square roots, and specifically, if I plug in 0 in the denominator, obviously t is going to go to 0, and the numerator will too. When I plug in 0 for t, I get the square root of 2 minus the square root of 2, also goes to 0. This is a 0 over 0 case. I'm going to multiply by the conjugating factor. And that's going to be, well, I'll just take the square root of 2 minus t and change this sign to a plus. And put that all over itself. Then I'm going to throw in all my parentheses, because you don't want to forget that. Right? So the reason this works, and we don't want to FOIL this out every single time, right? We don't want to write out that multiplication every time. But if you do it, what you'll always find is it's going to be the first term squared minus the second term squared all over, and we're just going to leave the denominator alone. Right, just rewrite it. So it's t times the square root of 2 minus t plus the square root of t. And I guess we don't need that much of a line there. Okay. And moving on, just rewriting this, simplifying it. Right? These square roots are going to disappear, so it ends up being a lot easier than we suspected. So it's just 2 minus t here minus 2 all over t times the square root of 2 minus t plus the square root of 2. Now be very careful here. These 2's cancel. And I'm going to do this as a separate step. You don't have to, but I just want to do it so we're clear and everything looks nice. Okay, we'll get negative t over t times the square root of 2 minus t plus the square root of 2. And now the t's cancel. And the reason I was careful about this is mainly because it's kind of easy to forget that negative sign is there when you just cancel everything out. So what we basically have is negative 1 all over the square root of 2 minus t plus the square root of 2. Okay. No problem, right? Now we can actually plug in the 0. right? Because that will not cause division by 0. Just plug it in, we'll get negative 1 all over the square root of 2 plus the square root of 2, which is basically just negative 1 over 2 square root 2. I should say that this is good enough for me. I actually think it's okay to leave square roots in the denominator, but your book, if you're checking your answers in the back, probably fuss at you for this. Or if you're plugging your answers in the online homework, it's probably going to want you to do this. Get rid of the square root in the denominator by conjugating, right? And so we'll end up with negative square root of 2 over, this will be simplified to be 2, and we'll get 4. But again, as far as tests and stuff goes, this is good enough for me. Okay, next example. We have the limit as x goes to 2 of 1 over x minus 1/2 all over x minus 2. So if I plug in 2, okay, I'm going to get 2 minus 2 down here, so that's 0. And then up here I'll get 1/2 minus 1/2, also 0. Okay, now this is not something we can factor. Okay, this is not something we can use conjugating factor on either, right? I don't see any. Move this down. Doesn't seem to want to focus. Okay, there we go. It's not something we can use like a conjugating factor on or anything like that. It's a case where we just have to simplify. We just need to use algebra. And there are so many ways, well, okay, maybe just two ways that we can really go about doing this. And the trick here really is, if I have some fractions I don't like, right, I'll just pick something clever that will get rid of all the fractions and multiply it. So this will actually end up being sort of like the conjugating factor, but we just use a multiplication factor. So here I have an x and I have a 2. So if I were to multiply this fraction by x, well, the fraction would go away, right? The denominator would cancel with the x. And if I were to multiply this one by 2, the 1/2 would go away, right? And you'd be left with 1. So if I actually multiply the top here, right, by 2x, well, 2x will cancel the 2 in this denominator and the x in this one, thereby getting rid of our fractions. Now, we can't just multiply on the top. Whatever we do to the top, we also have to do to the bottom. Right? It's the non-discriminatory thing about algebra. Throw in my parentheses, and then there we go. What we end up with when we multiply this through, I'll do this explicitly, it's going to be 1 over x times 2x, okay, minus 1/2 times 2x, all over. I'm just going to leave this as is, and you'll see why in a second. But here the x's cancel, kind of tough to cancel x's. Here the 2's cancel, right? So what I'm left with is the limit as x goes to 2 of 1 minus, oh, sorry, there's a 2 left there, 2 minus x all over x minus 2 times 2x. All right, we're almost there. Does everyone see that I have 2 minus x, x minus 2? These are almost the same. What do they differ by? Well, specifically a negative. If I were to take out a negative sign, right, factor it out, I'd get negative 2 plus x. And that's just a different way to write x minus 2, right? This here is technically x minus 2. So these cancel. And so we're left with the limit as x goes to 2 of negative 1 over 2x. And now we are free to plug in this value too, right? Because we will get negative 1/4. And we are done.